Good afternoon. Today we are presenting our CIM Computer Integrated Manufacturing project. The title of this project is Design and Fabrication of an Industrial Robotic Arm in Fusion 360 with DFA and DFM approaches. We have three members in a team. Myself, Mohammad Moiz Mughal. My other colleagues are Sorbi, Anil, and Sajita. Abstract: The project involved designing a cost-effective, high-performance robotic arm using Autodesk Fusion 360. In this project, first of all we fabricate and design a robotic arm by using Autodesk Fusion 360 software. So there are basically more softwares available in like SolidWorks and etc. to design, but Fusion 360 is most popular, and we just focusing on the DFA and DFM principle for advanced milling operation. In this process, we adopt milling operation, which is obviously machining operation, and to do that, we precisely perform our parts for milling operations. Introduction: Industrial robots offers speed, accuracy, and flexibility for tasks. As we know that nowadays all the modern industries are automated, and they adopt several automated systems. Like in bottle refilling, there are some robots and their automations involved to fill the bottles, and when go for the past, it doesn't happen. It only work for manual, and robots are also modern robots use AI sensors, CAD CAM, etc. Common types includes articulated like rotatory joints and Cartesian linear motions. This project applies industrial robots a principle using, as I already mentioned in my topic discussion, that we design and fabricate robotic arms assembly. Motivation for this project: to develop an affordable and practical robotic arm. Basically, we are designing this project for small industrial work and for the educational purposes to know how the practical and conceptual approaches of by using Fusion 360 software for efficient and real-world design and manufacturing processes. Project objectives. In our project, we first of all create a modular robotic arms. First of all, I'm telling you modular robotic arm means the the each module has the specific function and rotate 6 or more degrees of freedom. Then we apply DFM and DFA process, then design for CNC milling, generate manufacturing plans, and also generate G codes. The key components of this robotic arm assembly is base. Obviously, the whole assembly is based on this base part, and there is a base joint which support the upper and the lower arm of the lower upper and lower arm links, and then the wrist joint, it rotates on 3D motion, and they also support for end effector and then gripper is a main component of our assembly. Manufacturing phases. uh, as we know that manufacturing, there are machining cross operations. In this particular project, we adopt milling operations. In that milling operation, we adopt 3D adaptive, pocket, counter, scallop, etc. We perform we basically we change different tool paths, simulate and material selection for DFM and DFA process. Basically, we simplify design, reduce components, and better material quality for that purpose. In DFA, we merge wrist joint and housing to reduce the part count, simplified base shape, and reduce total assembly time. Basically, we adjust the assembly time and reduce the parts of assembly. The material selection, obviously, in our unmodified assembly parts, we use steel, which is more heavier than when we modify our parts and assembly. We adopt less weight material like aluminum, and also aluminum is corrosion resistant as compared to the steel, and also their machinability is good and easy as compared to steel. Their weldability is moderate, and their surface finishes excellent. Thermal conductivity high, but aluminum is non-magnetic as compared to steel. Here we show our design, like I say, in the unmodified modified base, you can see there is a circular steel structure, heavy and complex. When we modify it into the rectangular shape, which is light in weight and cost effective and easy to manufacture. And we also show some physical properties like in mass, like in the unmodified base part, the mass is 45,000 grams as compared to the modified. The modified part has 18,000 something grams mass. Similarly for wrist joint and housing, in the unmodified, the wrist joint and housing parts are different, but in the modified we combine it and reduce the part size and for the cost effective product. And also we use aluminum material for strength and corrosion resistance. Manufacturing processes. Here we apply CNC milling process operation for the precisions, and we use different tool paths, we use different tools, we change some geometrical informations, and we change several passes in on all the milling operation. Like first one is adaptive milling, then the second one is pocket, something like that. And the benefits of DFM are cost reduction, improved product quality, faster time to market, optimized use of material and resources, increased manufacturing efficiency. Design for assembly, DFA. DFA is to simplify the product structure so that it can be assembled more easily, quickly and cost effectively, as I already mentioned. Part count reduction, ease of handling and orientation, standardized fastener and infrastructure, material and manufacturing simplification, reduce assembly time and cost. These all factors are discussed previously. So basically in our project is, first of all, we design some product, and then we manufactured, and then we modified the parts. Here we see the area of improvement, like in the base part there is a circular part, the housing part, but after modification there is a rectangular part, and similarly to the wrist joint and the housing joint also. Here is our beautiful assembly of robotic arms. The top one is the original or unmodified robotic arm assembly. Then the bottom one is the modified uh, robotic arm assembly, and you can see that there is a difference between their base and both bases, and also their wrist joint and housing joint, and they both are rotate 360 degrees centigrade and 6 degrees of motion. And finally, we conclude that we adopt DFM as well as DFA methods to enhance their efficiency and reduce cost-effective system for modern manufacturing. Thank you.